day students, welcome to math.serve.com. In this clip we're going to be going over the properties of exponents. What we're going to be doing in this presentation is we're going to be taking a look at 11 properties of exponents. We're going to first of all look at the formula and then consider an algebraic and then a numerical example. Let's take a look at the first property, which is the product of powers property. Okay, so the formula is as follows. In this presentation, when I'm writing down the formulas, the assumption is that x and y are real numbers and the powers m and n represent integers. Okay, so the formula is as follows. Let's say we have x to the m times x to the n. The product of powers property just simply tells you that when you're multiplying exponents of the same base, you simply add the powers. Alright, so there goes the formula. Now let's consider two examples. The first will be algebraic. Example A. Let's say we have x to the third power times x to the fourth power. According to the product of powers property of exponents, you're multiplying two exponents with the same base. You simply add the powers, x to the 3 plus 4. Your final result is x to the 7th power. Now just a side note before we start example B, if you like to get a printable copy of the properties of exponents, including the formula, algebraic and numerical example, just look in the comment section below under the description, and you should find a link that will take you to a Google Doc containing the properties. Okay? Alright, let's take a look at the B part, a numerical example. So what if we have 2 to the third power times 2 to the fourth power? In this case, we're going to have, if we apply the product of powers property, we simply add the powers. 2 to the 3 plus 4, which is 2 to the 7th power. And then you can work this out with your calculator. 2 to the 7th power is 128. Now let's move on to property number 2. This is the power of a product. If you take a look at the name, you can basically guess what the property will look like. In this case, we are raising a product of some factors to a certain power. Alright? So the formula is as follows. If you have a product, let's say xy, where x and y are real numbers raised to the m, where m is an integer, the power of a product property basically tells you that you can distribute the power to the existing powers of the factors in the product. Okay, so assume there's a 1 here and a 1 here as your existing powers. The default power, if none is specified, you will end up with x to the m power times y to the m power. Now let's consider some examples. The first one will be algebraic. Example A. Let's say you have x y squared raised to the third power. Now according to the power of a product property, we're simply going to distribute this 3 to both powers. X doesn't have a power, so it's 1, so we're just going to distribute it. Okay, so that gives us x to the third power, y to the 6th power. So you have 3 times 1 and y to the 2 times 3. So we have x to the third power times y to the 6th power. And that's what you get when you apply the power of product property to an algebraic expression of this nature. Now let's consider example B. What if we have 2 times 3 raised to the 2nd power? Now if you want to do this using the order of operations, you take a look at the parentheses, you multiply these two, you get 6, and then you raise it to the power 2. 6 to the second power is 36. But let's apply the power of a product property here. So since 2 and 3 don't have any specified powers, we can just assign 1. That's the default power there. Now, according to the power of a product property, we can distribute this power to these existing powers. So we're going to have 2 to the 2 times 1, which is 2, times 3 to the 2 times 1, which is also 2. So we are now going to have 2 squared is 4 times 3 squared, which is 9. 4 times 9 is 36. That's exactly what we expected the answer to be. Now let's move on to property number 3. The third property is the power of a power. Okay, let's take a look at what the formula looks like. So let's say you have a power x to the m, where x is a real number and m is an integer, raised to the power n. What the power of a power property of exponents says you can do is that you can simply multiply the power. So you have x to the mn. Okay, so that's the power of a power property of exponents, and this was highlighted in example number 2. But let's take a look at another example here, an algebraic example. Let's say we have x to the third power raised to the second power. What is this going to be? It's simply going to be x to the what? According to this property, you multiply the powers. You have x to the sixth power as your expanded form. Now let's consider a numerical example. Now let's say you have 2 raised to the second power raised to the second power. If we use our order of operations here, we have 2 squared is 4. 4 to the second power is 4 times 4, which is 16. So that should be our answer. Okay. Now let's apply the power of a power property. You have 2 squared raised to the second power. So according to this property, we multiply the powers. You have 2 to the 2 times 2, which is 2 to the fourth power. And if you raise 2 to the fourth power, you have 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and there you have it. Moving right along, let's consider property number 4, which is known as the quotient of powers property. Now, what does the word quotient mean? It just basically means division. Okay? So what happens when you have the quotient of two powers? Basically, what happens when you divide in two powers? What if they are of the same base? Let's take a look at what the formula tells us. Alright? Formula is as follows. If you have x to the mth power divided by x to the nth power, basically you have the quotient of two exponents of the same base. What you simply do is you subtract the exponents. X to the m minus n. Okay? You can draw a parallel between this and the product of powers property. Remember when you're multiplying in, let's take a look at it. In the first one, what did we do? We added the powers. When you're multiplying exponents of the same base, you add the powers. But when you're dividing, think about division as the inverse of multiplication. When you're dividing, you do the inverse of addition, which is subtract. Okay? Alright, with that in mind, let's consider some examples. Let's start out with an algebraic example. What if we have x to the 7th power divided by x to the 4th power? According to the quotient of powers property, when you're dividing two exponents of the same base, you subtract the powers. 7 minus 4. Okay, and then we're going to end up with x to the third power as your final result. Now let's consider a numerical example. What if you had 4 to the fourth power divided by 4 to the second power? Applying the quotient of powers property, since the bases are the same of these two exponents, when we have a quotient, we subtract the powers, and we have 4 to the second power. 4 squared is 16. Okay, so there goes your final result. Alright, moving right along. Property 5 is the power of a quotient property. Okay, power of a quotient. Now, as the name indicates, you have a quotient that's been raised to a power. Now, what's the rule here? Let's take a look at the formula for the power of a quotient property. So let's say we have two real numbers x and y. We have their quotient raised to the power m. What the power of a quotient property tells us we can do is basically distribute this power to these two terms here, the numerator and the denominator. So we are going to have x raised to the m power as a result of distributing m to x divided by y to the mth power as a result of distributing the m to the denominator. Okay, so there goes your formula. Now let's consider two examples. We will start with the algebraic example. Now, what if we had two real numbers x and y, and we have x over y raised to the third power? What does the power of a quotient formula tell us we can expand this into? This basically becomes x to the third power divided by y to the third power. Okay, so that's the result of applying the power of a quotient property. Now let's take a look at a numerical example. What if you have 5 over 3 raised to the second power? If you apply the power of a quotient property here, you end up with 5 squared as a result of distributing the 2 to the numerator divided by 3 squared when you distribute the power to the denominator. 5 squared is 25 divided by 3 squared, which is 9. So there goes your final result. Okay, property number 6. Property number 6 is pretty straightforward, but it's one of the easiest properties to forget. This is the infamous zero property. Okay, so let's say you have a real number x. Let's write down the formula first. If you have a real number x raised to the 0th power, the final result is 1. Okay, now let's consider a numerical example. What is the answer of the expression 25 raised to the 0th power? If you raise 25 to the 0th power, your final answer is simply going to be 1. Okay, as a result of applying the zero property. Alright, let's take a look at property number 7. Property number 7 is the negative. I also like to refer to this as the reciprocal property. Okay, the negative or reciprocal property of exponents. Okay, so negative or reciprocal power property. Okay, what's the formula? Formula is as follows. If you have a real number raised to negative m for some integer m, what this negative exponent does is it enables you to reciprocate the term with the negative exponent. So x has a negative exponent associated with it. Since it is the numerator, this negative power can cause it to get reciprocated to the denominator position. So it's in the numerator, we can reciprocate it to x to the m. You notice that as soon as it switched its position to the denominator, the negativity of the exponent disappears. Okay? So that's the negative or reciprocal power property. Now let's consider an example, actually two examples. Let's start with a algebraic example. What if we have x over y raised to the negative 2 power? Okay? So let's see what we can do here. X over y raised to the negative 2 power. Now, if we apply the reciprocal property of exponents here, what is going to happen is that this negative will cause this fraction to get reciprocated. So we have y over x. And then the 2 gets distributed to both terms, y squared over x squared. Alright, so there goes your final result. Let's take a look at another example, a numerical example this time. What's the result of raising 3 to the negative 2 power? If we apply the negative or reciprocal power property, this 3 in the numerator gets reciprocated to the denominator because of the negative exponent. So you have 1 over 3 squared. This can be simplified further into 1 over 9. And there goes your final result. Moving right along, property number 8. That is the nth root property. Okay, what the nth root property does in a lot of cases, it enables you to rewrite a root expression in a format that makes it possible to reduce. Okay, or sometimes you might want to understand what the scenario is just by rewriting it using the nth root property. You can be able to solve a problem that looks awkward initially. So what is the nth root property? Let's take a look at the formula. The formula is if you have a real number x raised to 1 over m, where m is an integer, this is the same thing as taking the mth root of x. Okay, let's take a look at two examples. Let's start with an algebraic example. Let's say you have a real number y raised to the 1 over 3. Applying the nth roots property, this basically becomes the third root of y. Alright, so that's that. Let's look at a numerical example. What if we had 27 raised to the 1/3 power? Now, some people might look at this and wonder what on earth is going on here. We are raising a number to a reciprocal power. To a fractional power. How on earth do I do this? Well, if we apply the nth root property, it becomes less intimidating. This can be rewritten as the third root of 27, also known as the cube root. Okay, so this might look much more familiar, less intimidating compared to this formulation here. So what is the cube root of 27? What number do you multiply by itself 3 times to get 27? The answer is 3. Okay, so that's one of the beauty of the nth root property. It enables you to rewrite expressions in such a way that it's easier to handle. Now let's take a look at the ninth property. This is the special case of the nth root property. Okay, special case of the nth root. Okay, so what is the special case of the nth root property? The formula is as follows. If you have a real number x raised to the 1/2 power, this can be written by applying the nth root property. But what makes this special is that when you write it in its radical form, you do not have to put a 2 there. Okay? You just write it as the square root of that number that has the power of 1/2. Okay? So this is a special case of the nth root property. Now let's consider an example. Let's start with an algebraic example. What if you had a real number y raised to the 1/2 power? Applying the special case of the nth root property, this is the same thing as the square root of y. Okay? Now let's consider a numerical example. What is 81 raised to the 1/2? You might present this problem to certain students and they might wonder what on earth is going on here. They might try to divide by 2 or some other thing. But if you apply the nth root property, you can rewrite this as the square root of 81, which everyone knows is 9. Alright? So there goes the special case of the nth root property. Alright, let's take a look at property number 10. This is known as the fractional exponents property. It's also connected to the nth root property. Okay? Now, this is the formula. What if you have a real number x raised to a fraction, namely m over n, where m and n are integers? Applying the fractional exponents property, this term right here can be written in two formats. The first is the nth root of x raised to the m power, or you can write this as the nth root of x, the entire thing raised to the mth power. These two formulations of this term right here are exactly the same. Okay, so you just have to look at the problem and what you're trying to do in order to determine what is the best formulation to use. Okay, now let's take a look at two examples. Let's start with the algebraic example. What if you were asked to rewrite the term or the expression y raised to the 4/3 power as radicals? Using the fractional exponents property, this can be written as the third root of y to the 4th, or you can write this as the third root of y, the entire thing raised to the 4th power. So in this case, you have two possible answers. Now let's take a look at a numerical example. What is 8 raised to the 2/3 power? Now when you apply the fractional exponent to a scenario like this, it makes the problem much more manageable. Okay, so this can be written as the cube root of 8 squared, which involves raising 8 to the 2nd power and taking the cube root, or you can rewrite it as the cube root of 8 raised to the 2nd power. Now these two are the same, but one of them is actually easier to do. A lot of students know that the third root of 8 is 2, so you can just take advantage of that fact and write the third root of 8 as 2, and then raise it to the second power, and your final answer is 4. Okay, so sometimes just writing it in these two formats can help you decide which one is easier for you to pick, which one is much more familiar. Taking advantage of your knowledge of exponents and the roots of powers. Let's take a look at the last one, property number 11. This is known as the root of the same power property. Okay, what if you're taking the root of a power and the root and the power are the same value? Let's consider the formula. The formula is as follows. If you are taking the nth root of x to the n, where x is a real number and n is an integer, there are two possible outcomes depending on whether the power n is even or odd. Now let's consider both cases. If n is even, your result will be the absolute value of x. Okay, that's if n is even. How about if n is odd? If n is odd, you just end up with x. Okay, the power and the roots just simply cancel each other out. So if n is odd. So that's the root of the same power property of exponents. Now let's go ahead and take a look at some examples. Example A. What if you were asked to evaluate the expression the square root of x squared? The root is 2 and the power is 2. So what's the final result going to be? Since 2 is even, your final result is going to be the absolute value of 2 of x. Alright, so let's write that down. The absolute value of x, just because 2 and 2 are even. Okay. Now let's take a look at a numerical example. What if you're asked to find the square root of -2 squared? Now we have even power and an even root again, so we're still looking at the first case. If we apply the root of the same power property here, we're going to end up with the absolute value of -2. What is the absolute value of -2? The absolute value of -2 is simply 2. Okay? So there goes your final result. Thanks so much for taking the time to watch this presentation. We really appreciate it. As indicated earlier, if you'd like to download a printable copy of the properties of exponents, just look in the description for the link. If you have any questions or comments concerning the presentation, just place your questions in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other cool tutorials such as this. If you found this presentation helpful in your study of exponents, do give us a thumbs up. Your positive feedback is very valuable to us. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.